Oh, hello there. It's me, and I don't know how to start, so I'm going to just talk for a bit until I think of a way to start. I guess I've sort of left what I was doing hanging for quite a while, and if you were paying attention or following any of this, the last thing I was doing to do with this, I now have yet another channel. I keep adding work for myself and I never get paid for any of it. But the last thing I was doing on this channel was, this is another channel. The aggregation calm thing, and then I wanted to talk about marshalling. In fact, I just started, I did one video on it, and then I started working with this collection of DVDs that I have, see, and it's a great big collection, and it took a long time, during which time my computer was essentially not usable, at least for making videos, because I was trying to convert all these DVDs to another format. In fact, and I did that, but that was a very lengthy operation. It took many days. Here they all are. They're all AVI files. And I have them backed up on my F drive. I'd like to move them all over here, but I don't know if I trust this drive completely. One file got corrupted somehow. Although I have to admit, I pushed the machine several times beyond its capacity, and it just rebooted spontaneously from either from overheating or too much activity or I don't know what. And one of the files got corrupted. It was one of these MPEG files. In fact, I still have just this one left. One of the things I did in the meantime while working with these was to create yet another hook for Virtual Dub. Not for Virtual Dub itself, but for one of the add-ons, one of the plugins that opens these MPEG-2 files. And when it's reading them in, it takes quite a while for it to finish doing that. The system really grinds down to a halt. I wanted to use my asynchronous read with that, somehow make this thing use the asynchronous read. And so I did some work and I had to change the way it works, because as it is now, it's not really amenable to applying it to an arbitrary situation where somebody has a file handle and is recalling something repeatedly, right? Whereas the way I had it, there was only one call, and then you would get called back on. Well, I still have that, but I altered it in such a way that you can call the thing repeatedly, even though the reading thread dies and everything. The next read, you create a whole new thread, and it can pick up where it left off. In fact, I've got the code in here somewhere. Will be under end thread, which is something I want to talk about to do with marshalling. Is that marshalling the threading thing? Oops. I'm planning, secretly in my mind, I know I'm planning to turn all these into DLLs, but not static libs anymore. Just because I think it'll be easier from this point on to use DLLs. Initialization is easier, and things are there are a lot of advantages to the DLL way. So now let's see. There's a worker. Now previously there was just a static function that you called, and it would make one of these objects secretly internally an overlap thing. But if I want to hang on to that overlap thing, I have to make it exposed. So it no longer works that way. You can declare one of these objects, right? Just declare one and start using it. And it has various features, like you can set the file position. If you want to get the current file position, that's actually required, right? If I'm calling it over and over again. Open a file. No, actually I can get rid of this part. This was a FACO file handle, right? Not a file handle at all. Oh, well, it can just return a file handle instead of returning a bool. Because what I do, I copied it into my dynamic area where everything really is, DLLs. But that doesn't have a lot of the bug fixes I've done. I've managed to get done with this version. So I copy that code into here. And so it's in common. I don't have an mthread DLL, just have common. And yeah, updating intelligence. Intelligence update. We're now down here. Oh, no. Yeah, that is where I am. No, it's not. Read. This looks different, but it shouldn't be. Bool open feed handle. Okay, now where's my hook? It'll be a kernel 31, possibly this one. I have several with the same name. Whoops, that's never the right file to look at. In this case, it's not. This pause has nothing to do with the intelligence. This has to do with this idiotic feature that it's going to back things up for me. Thank God that it's got a backup ready that I'll never use, and that it's going to be corrupt anyway. And I can't seem to turn it off. You can only set the amount of time between backups to a maximum of 60 minutes or something. Oh, so it's dead. I have to kill it. Well, and also this is a pretty mighty operation going on here. Yeah. Right, in the def file, which is kind of like the header for as far as the DLL is concerned. This looks like it. Yeah. Read file, set file pointer, override that. I have overridden create file, read and close handle. No, I didn't do that pointer. Don't need to. So certainly I need to know when the file is created, right? And make sure it's open with the overlap flag. So here in let's close handle. In create file, if the access requested is a generic read, I make myself a new one of these overlap type things. And then now this is an actual file handle. Previously I was just returning a pretend handle, which was actually a pointer to one of these things. But that's no good because people are going to do things with those handles you give back, like maybe try to seek to the end or seek to the beginning and figure out the size or something. So I can't do that really, and so this open actually returns a file handle. See, it turns a bool and puts a handle in here. You see, this is probably better actually because the error return is not 0, right? It's this -1 stupid thing. So actually this is probably a better interface for open than the create files stupid thing, which you can't say if create file. That's the natural thing. So now where are we? In the wrong file. So hred is an actual handle, and I return it if open succeeds. Otherwise, I delete the thing that I just created. If it wasn't for read, then I just called the actual function. Now, when it comes to reading, first, this overlaps thing now comes equipped with a located function that tries to see if the file given happens to be one of the ones that it's managing. So this find is simply a lookup as a map of handle to file to this pointers. And if that turns out to be true, then the return value will be a pointer to one of these objects. And now the way I'm doing it, I don't have to. I could use a buffer the size given. It turns out that plugin requests reads of buffers of size 64K, one DOS segment. But whether or not it helps doesn't matter. I want to make sure that this functionality is working, which is that I'm choosing a smaller buffer. Right. Here's my buffer is just like one page, and I want to use that buffer for the depositing of the reads. And each time a read completes, I want this function to get called, and I want this to be passed to this function, this piece of data, and this is the total number of bytes I would like read. Now this PPV data is just the address of the buffer that was passed in. So here's my completion routine. This completion routine is being called from a different thread than the thread that executes this line. Although there's no need for any synchronization checks because this call is blocking and doesn't get to this line until this is completed, so it's all safe. And then what I'm doing is casting this as what it is, a pointer to buffer. Copy the data, the amount of data in that was just read, which will be some number up to 4096. And then I'm incrementing the current buffer, this pointer that's passed in, right? Now that's kind of interesting in itself, because you might be wondering, well, what's the value of this thing going to be when the function returns? And the answer to that question should be pretty obvious. It shouldn't be changed at all. Because a copy of this is what will be passed repeatedly to this thing, right? In a different thread and on a different stack. So the one on this stack should be left unchanged, I think. Let's see now. This is saying address of this variable. This thing here is a pointer to bytes, and this is taking star of the thing passed in and then incrementing it. It does work. I was kind of surprised it would. So PPV test will be altered, and let's see, how is that passed in? I wonder, I haven't actually stepped through it to see. It doesn't matter because I'm not returning that, right? That's my own variable, right? It's not something that the user of this function supplied. That's the LP user, which is given to the worker thread thing. Okay, that LP user is a copy of the thing pushed on the stack, but that's not the one that's being incremented. It's what it points at, right? Because I'm taking the address of buffer. Maybe it will change. Doesn't matter, because this is already a copy, right? This LP buffer is a copy of a pointer pushed on the stack, and this thing might modify that copy, but the pointer that the plugin passed in shouldn't change. Shouldn't be changed. Well, if it did change, the whole thing wouldn't work, and I know it does work. Let's see now. Can I run this? Come over here. What will it do? It should run vdub. Okay, no arguments. Let's see. I think this is up to date with what's over there in the program file. Now, with 6 that has a M on F only. Here, I gotta put a breakpoint. First, you'll notice that it tries to open 2 files. It tries to open one type of file. If it doesn't find it, it tries the next. And it's not. So the first attempt won't be the file that I've chosen. Okay, it's trying to read, but the file name is mpeg.mivx, probably is an index file, right? Okay, so then I try this, I malloc one of these things, and then I try opening it myself, and that didn't succeed, so handle ref is invalid, and I delete it. Oh, and I could just return href here, right? But instead I let it go through this as well. Now it comes in here again because it couldn't find that one, presumably, and try again. This time I did get something. I got a handle. That's what a real file handle is, usually a small number like that. So return that, and now it's trying to read. The handle is C. So here, now I'm going to check to see if the handle passed in is one of mine. It turns out that it is. And this thing then returns the associated TS overlap star for this handle. And there's a synchronization object involved in this assignment. So this is a thread-safe assignment. Now, this is a stack pointer to something on the stack. And I'm passing it into read here, which is going to run the thread in chunks of this much per read until it hits the end. Now, I'm just going to step over and see if this value changed. No, it didn't change. Oh no, but what it pointed at, was that changed? LP buffer. Not listed, I forgot to check what it was. Well, we can check on the next one. LP buffer is that number. Come on. Let's see if it changes. It went red. I guess it did change. And what's it pointing at? Did it change? That looks correct. That looks like the data. We'll try it again. Okay. Here's what LP buffer is pointing at. Something with a D0. So it didn't actually change. See? Although this thing is changing that pointer internally every time it makes a read. Right? Data got written in here. This is all zero, but eventually it stops being zero. This always the same? Yeah, it's the same buffer every time. Nothing this time. There's a lot of zeros before you get to the actual data. But faster than that. It's just getting almost everything. Is this thing working properly or not? Oh, there we go. See what I mean? Once you hit the data, then a lot of other stuff. No, from now on, it's going to be lost. It's funny that these bytes, though, D0, these ones are always the same for some reason. I wonder where that would be. They are aligned. Maybe there's a standard type header that appears at these boundaries. Because actually 64K is a special number on my machine. That's the minimum allocation size for something. It's the minimum allocation size for a block of virtual memory or something. You can't make a block smaller than that if you use like a virtual alloc. Alright, so now let's get rid of the breakpoint. Put one more here at the end. So now, as this thing is running, this here is reading using asynchronous IO, and my machine is not locked up. Everything is responsive, well, except for the fact that there are two other highly CPU intensive things going on. This thing and this thing use up a lot. But this one no longer is using very much CPU. It's not, sorry, not CPU. Bandwidth on the bus. It's not jamming the bus as it used to do. And once or twice, I got into a locked bus lock situation, and I had to press the reset button. So it was important to fix this problem. Anyway, I've talked too long. Maybe I can get something out of this initially.